Welcome, pre-calc honor students. Flange here. Sorry about that. I'm going to have to redo this with the microphone on this time. Here we go. Quadratic functions and their graphs. We've got three forms to look at. Maybe this vertex form, or I'm sorry, the factor form is new to you, but it's going to be handy in some of the word problems we do. And for each of the forms, we're going to look at the x and y intercepts, the axis symmetry, and the vertex. Now, if you notice in each one of these forms, we've got this a sitting out in front here. What is that all about? It shows up in every form. Turns out a, the sign of a tells you the concavity of the parabola. So if a is greater than 0, you get your happy parabola. If a is less than 0, you get your sad parabola. This is called concave up and concave down. Some kids memorize in terms of a is for attitude, and the little circle, the little eyes there, there's a positive attitude student, very happy. There's a negative attitude student, kind of sad. What if a equals 0? Well, then you just plain don't get a parabola anymore, do you? You don't get a parabola. What do you get? Well, let me know what you think. Standard form, y equals ax squared plus bx plus c. This is nice because it tells you the c right away. You get the y-intercept out of it right away. X-intercept's a little trickier. You have to set 0 for y, and now that should look familiar. That's your old friend, the quadratic equation. And you use the quadratic formula to solve it. You also have, if you can see how to factor it and so forth. Now, one thing to get out of this too, though, is that the axis of symmetry is halfway in between the two roots. Here are your two x-intercepts, there's your y-intercept. The axis of symmetry is halfway between the two roots. So, negative b over 2a is that halfway point. Here's the little mini proof. That if you go halfway between the roots, that is the average of the roots, negative b plus the square root of b squared minus 4ac over 2a plus negative b minus the square root of b squared minus 4ac over 2a, all divided by 2, and if you add those up, this radical part cancels. You get negative 2b over 2a, all divided by 2, and those cancel. Actually, there's your negative b over 2a. Now for the x-coordinate of the vertex, it matches the x-coordinate of the axis of symmetry, negative b over 2a. For the y-coordinate of the vertex, you have to memorize this formula, but you could derive it by putting negative b over 2a into synthetic substitution and coming up with this 4ac minus b squared over 4a. Some kids actually like to memorize that. I think you're better off just using synthetic substitution or direct substitution to plug in to come up with your y-coordinate vertex. Now, the factored form is handy because it gives you the x-intercepts quickly. It's just root 1 and root 2. When you set equal to 0, you can set x equal to root 1, x equal to root 2. The y-intercept, you'll set x equal to 0, and you'll get a r1, r2. Again, another formula, not so key to memorize. This is the key concept, getting enough of the factored form, the roots. The axis of symmetry lies halfway between the roots, and then your vertex is going to be at x equals root 1 plus root 2 divided by 2. Now, how do you get the y-coordinate vertex? Well, plug the x-coordinate of the axis of symmetry into the equation and figure out your y. Finally, we have vertex form. And the handy thing about this, notice I'm changing the order here because it's not so easy to find the intercepts or the x or y. But the axis of symmetry is right there, x equals h, and that leads to the vertex to it, h comma k. To find the y-intercept, set x equals 0, you get a h squared plus k. To find the x-intercept, you're going to have to set y equal to 0. Solving for x, you get kind of a complicated expression, h plus minus the square root of negative k over a. I wouldn't memorize this, but it's kind of fun to analyze what happens. Let's say if h and k are positive and a is negative, that means we're going to have a parabola with a vertex in the first quadrant, and it's sad because a is negative. That will definitely have roots. And sure enough, if a is negative and k is positive, then this whole expression here is positive. So you can take the square root of a positive number, and you go h plus or minus that square root of negative k over a. Let's wrap up by practicing with doing a quadratic function. Y equals negative half x squared plus 5x minus 9.5. We can get the axis symmetry with a little mini formula of negative b over 2a. So there's your 5 for the axis symmetry. Y-intercept is just this last term, negative 9.5. I did the roots over here, and I did the quadratic formula to solve for them. Getting 5 plus minus the square root of 6, that's about 2.5. And then I plugged 5 into the formula to come up with 3 for my y-coordinate vertex. So when we plot it, there's our roots, 5 plus minus square 6. There's the axis of symmetry at x equals 5. Here's the y-intercept, and here's the point symmetric to the y-intercept on the other side of the axis of symmetry. So I'm going to be looking for these 5 points whenever possible. You're always going to have a vertex. You're also going to have a y-intercept. Now, the y-intercept and x-intercept might be the same thing, so then look for a few more points, but 5 is a good number to draw. And if we compare this to what we've got on GeoGebra, we did a good job. Flange out.